We have Bob Neild from Engineering Ventures, Tom Perry from New Leaf Design, Chuck Reese from Reese Building and Renovation, Alex Tolstoy from Preservation Trust of Vermont, and also his own business, Vermont Property Preservation Consultants, Sandra Vitztum, architect, Steve Spatz is an energy consultant and manager with Efficiency Vermont, and I'm Judy Hayward, again, your moderator for the day, executive director at the Preservation Education Institute and Historic Windsor. We're going to be teaching a process today for cooperation and how to address those site-specific challenges. We may have to agree to disagree on some topics. We found this to be true as we were planning the content. We all don't agree on every single method for either energy conservation or preservation. So we want to create an environment for civil disagreement today. And I think that's really important because we're going to learn from each other as much as learning from the panelists and presenters. And I think it's going to be really important for us to remember that we are all here today because both energy savings and historic buildings matter to each of us. We set 5 learning objectives for today's program. And when you finish our training this day, you should be able to understand the key differences in pre-World War II construction that require special consideration in retrofits. You'll be aware of risks of treating historic assemblies and materials like modern ones. You'll understand an approach to historic building retrofits that protects original construction, yet meets energy code requirements. You'll know where to get further guidance for working with particular assemblies and materials. And this is an important concept. You're going to learn how to optimize energy performance of an historic building while preserving or restoring it. We talked long and hard in our planning sessions about not compromising. We want to optimize. And so some of the key takeaways are the solutions typically are site specific. We want to optimize energy performance and protect historic building fabric at the same time. And so it's about making the best of both and not settling on an unwelcome compromise. So with that, I'd like to hand it over to our first speaker, and I believe that is going to be Alex Tolstoy from Preservation Trust of Vermont.
Great. Well, thank you, everybody. My name is Alex Tolstoy, and again, I work for the Preservation Trust of Vermont, which is a nonprofit that works with community groups and homeowners around the state to help preserve historic buildings and gathering spaces. I'm also a builder and a private preservation consultant. And I've been asked to very quickly go over what historic preservation is. So what is historic preservation? One of my favorite quotes is from a Connecticut preservationist, Harlan Griswold, who said, "Preservation is more about my grandchildren than it is about my grandparents," which I think is a great reminder to all preservationists that we have to look forward as much as we look backwards. And that these buildings, yes, they tell us about our past, but I think almost more importantly, they're a tangible connection to the past. When we walk into historic buildings, they elicit different sensations, right? We have different smells, they have different feels, different sounds. When we look through these old windows, it gives us a different viewpoint on the world outside and on the world inside. And it's these differences from new buildings that I think cause us to have such strong memories and strong attachments to these buildings. And that's why I think so many people are willing to fight for these historic buildings. And they become kind of the stages of our communities, literally in this case. And they become such a source of pride in our communities. And that's what I think makes our communities special. So once we have these buildings, it's up really to us to care for them. We become the stewards of these buildings. And it becomes our kind of custodial duty to take care of them and to ensure that they're here for generations to come. But I think it's also important to acknowledge that it's not our only responsibility, that we also have a responsibility to our community and to our environment to care for it. And we have to kind of find that balancing act that Judy was talking about of our responsibilities. And sometimes that might take thinking about them in different ways. And what do I mean? One way is embodied energy, which is, I won't go in too deep depth about it, but it's a way of calculating the total energy that goes into harvesting, producing, transporting, and creating materials. So where did these bricks come from? What kind of energy was used to produce them? Where did the lime come from for the mortar? How are these stones transported to this site? What kind of machinery was used? And I think we can start thinking about embodied energy as creating this kind of larger definition of carbon footprint. And so when we think about the materials that use this wall in Fairfield and the carbon footprint, it's probably a lot less than the materials used and the energy used to produce these materials. So again, we have to think about these buildings not only as cultural resources, but also as environmental resources, that it's more sustainable to preserve these buildings than to tear them down and build something new. And I think that's a great way of thinking about it and our responsibilities for both our environment and our communities. So what's next? So our first step as the stewards of these buildings, we have to think about what exactly makes them historic. What makes a historic building historic? In preservation, we call these character-defining features. It can be the windows. It can be the fenestration. It can be the size, the scale, the street, how it takes part in the streetscape, as we call it. It can be interior features like this plaster medallion, which has seen better days. I think structural elements can be character-defining features sometimes, like this timber frame in Hartford that has marriage marks from the 18th century. Fixtures and appliances can be character-defining features in some instances. You know, this sink, the steam radiator, they can be character-defining. What does it say about the occupants? What does it say about why were they installed? Was this the new technology of the time? What does it tell us about the people that live there? A lot of time, the character-defining features can just kind of be the overall style of a home, like this very high style Gothic revival house in Stratford. Why was this built in such a rural community? What was the home of Senator Justin Morrill? And so what does that tell us about that community and who he was and the style? And once we kind of add up all these different features, we get a better sense of what really defines buildings and what's worth being preserved. So what does that mean for us? It means when we're working on these projects, we have to find that compromise, that balancing act. And we also have to manage our expectations. And I think if you're a builder or an architect here, it's probably one of your biggest jobs when working with clients is managing expectations. We have to accept that change needs to happen, but also understand that there are certain elements that have to be preserved to keep these buildings historic, so that we can look at it and we can see a 18th century Cape Cod style house, but that it's also comfortable and livable. As preservationists, we have to accept that there are new definitions of what comfortable living space is. And so, again, that's going to be part of the compromise. This is my childhood bedroom, actually. No, I'm kidding. We have to think about the materials that we use and how they will affect the historic materials. So what will this foam do to the porous materials underneath it? Is it reversible? And I think that's one of the main takeaways from today is we have to think of ourselves kind of in this one period where there's people before us and there's people that will come after us. And what we do to these buildings, we have to hope that it can be reversible if need be. We have to look at historic materials and new materials in terms of their serviceable life. How long will they last? What is their integrity now? So as a preservationist, yes, I want to save historic plaster, but I also have to accept that sometimes it's lost its historic integrity and it's not worth saving. And so the question becomes, what do we replace it with? Is it worth replacing it with new plaster? Or can we do blue board with a skim coat? Or can we just do it with drywall or some other type of interior finish? Something that's near and dear to my heart is maintenance. We have to remember that buildings require maintenance. No matter what the vinyl or aluminum salesman says, buildings take ongoing care. We need to take care of them and maintain them. And that's not always a bad thing. You know, like these 1820s windows that I restored, they can last another 200 years if they're just well maintained with a new coat of paint. And I think that ultimately that's better for the environment if we keep things out of the landfill. And once we get on that replacement train, it's pretty hard to get off. So specifics, when we're thinking about insulation, again, we have to acknowledge that buildings need insulation. But so what do we actually use? Do we use a irreversible material with a high R value? Or can we use a reversible material like this cellulose with a slightly lower R value? Can we just manage the moisture and vapor and air barrier and then think about how else we're going to tackle a thermal barrier? Or maybe is it necessary? Rather than replacing all the windows in the house, maybe we can invest in the existing windows and add storm windows. I think this model was actually made by the homeowner with just a table saw and a skill saw. I think they look great, and they have screens that can be interchanged. Low-hanging fruit for me is replacing inefficient heating sources, like this gravity-fed system in Swanton. But then the question also becomes, what's the best option for a new efficient system? Like, does this heat pump detract from the crown molding and these high ceilings? Would a better option be a floor-mounted system? These are the questions that I think we want to ask. And I think that's kind of the biggest takeaway for me is that it needs to be a conversation, that it's not going to be a one-size-fits-all approach. It can't be. So just to summarize, we have to remember that these buildings, not only are they homes, but they're cultural resources, like this workers' housing in Burlington. What does that tell us about that community? We have to think about the specific features of these buildings that are important and worth saving. And finally, we have to think about how we care for our buildings. Now, in the future, what will we be able to do? What will we be able to remove or replace? And I hope that just kind of briefly summarize, brief summary of what historic preservation is. But again, I'm looking forward to this conversation. It's something that's really important to me. So thank you.
Thank you. That was a really, really great introduction, Alex. Alex and I have been working on this building down in Pittsford. It's interesting because it's not in an historic district. It has a lot of meaning to its family, and it's a great example of how I think COVID has one huge benefit, has encouraged us all to slow down and understand the life and uniqueness of of really every building, like every person. As we slow down, we can focus on being more inclusive rather than being exclusive in the, the traditional historic sense of a historic building. If it's historic, it's got to be nationally recognized. So here is an historic building on the quiet edge of a very quiet town. And Alex is going to take us through the beginning of it. And we're looking at these steps of how do you make a plan for this building. This house actually has been in the same family almost since it was built. And they're not sure what to do with it. And so it's a very personal and private adventure. This as it switches generations that they're taking on. And it's going to ultimately be a personal decision for them of how they balance the building with the environment. What we're helping them do is go through a process to assess all of the aspects of preservation and environmental conservation. And this morning we're going to get into the kind of the beginnings of the weatherization. So looking at the different parts of the building. And then this afternoon, using a different case study, Tom and Chuck are going to get into the actual kind of the energy considerations and thinking about it using a process that they call Zen. But let's start with assessment of a building and beginning to set out the plan. So Alex is going to take over.
So again, I think the first step in any of this when we're working with buildings is to assess what is significant. We have here a late 19th century stick-built, I'd say medium style house in a very rural community. So we have to think about not only what's important to the overall style, but what in this particular house is important. So just kind of loosely looking over it, I think, again, kind of that overall size scale of the house is important. The size of the windows, where the windows are, the overall plan, these are all significant features. Where it has lost some significance is that the windows have been replaced and the siding is covered with aluminum. And I think that's a major factor, especially with this style of house, that the siding is at least covered with aluminum. And why do I say that? Sandy, if you can go to that historic slide. I know this is not the best quality photo, but we can kind of see the faint outlines of that, of the cedar shingles up on the gable ends and the belly band, and then clapboard in between. And then under some of the windows, we have ornate detailing. Some of those historic features remain. Some of the scroll work is still there, but a lot of it is gone or at least covered. So to really maintain or to say that it has its historic integrity, we want to restore the siding that's underneath the aluminum or replace it in kind. Next. Again, this porch, I think, is definitely significant, at least this kind of detailed work. When we think about Queen Anne style houses, we think about being true to the materials used and displaying the craftsmanship that was available at the time. I think we're seeing that here with this porch roof. So I definitely say that it maintains its significance. Not pictured is the lower section of the porch, which has PVC railing and I think composite decking, which is kind of a compromise, right? Again, the maintenance-free salesman has struck again, but it's something that we can talk about. Next slide. And yeah, we have these side porches. In the historic photograph, you can faintly make out that this side porch actually wrapped around to the front porch and that it was uncovered. And for anybody that has an uncovered porch in Vermont, I think we can all attest that they don't last, they don't last very long. But I think, again, these porches are character defining and they maintain their integrity. And this is another kind of great view of some of those details that have remained. You know, the aluminum has tried to mimic some of the details that were probably underneath, like we can see in that gable end. I think it's great that the window sizes have been preserved. We're seeing those kind of very thin little windows in that bay. Great. Next slide, Sandy, please. Again, the windows are really important. And here on the right-hand side, we can see those climbing windows, and those are actually stained glass, and those have remained, and those are beautiful windows that have remained. And then up in the gable, we see these quarter round windows around the chimney. Those are historic and are existing, and I'd say that those are definitely character defining features, and we'll see a better picture in a moment. But the chimneys are also character defining in this instance. And they're in overall great shape. Next slide, Sandy. Here's some of the interior. Again, first we're just gonna kind of look at this overall foyer, right? When we think of this time period in this style of building, they normally have that grand entrance with a grand stairway and grand foyer. This has some alterations, so it's right on the cusp of maintaining its historic significance. Those stained glass windows, I mean, they're just beautiful, and I think they really help place this building in that time period. Next slide, Sandy. Yeah, here's another great view. I mean, this staircase is just incredible, and the stained glass. I think this might be the most important room in the house. But we'll go and we'll look at some other interior features. Next slide, Sandy. Oh, so sorry, the windows. Here's the interior detail of those remaining historic windows that are not the stained glass. This is on the 3rd floor, and they've really maintained their integrity. It's going to be interesting to see how these last versus the vinyl replacements. Next slide, Cindy. Here's a detail of a new vinyl window that was put in. Luckily, they maintained some of the historic features like the wood stops. It looks like they were just kind of inserted into the opening. So again, you know, it's kind of that calculation that I think preservationists make when we're looking at these buildings of how much remains and how much has been lost. And then it's the overall question of integrity. And this building is, again, kind of right on the cusp on the exterior of losing its integrity because the siding has been covered. So in talks with the SHPO's office, the Division for Historic Preservation, they're really going to push for this building to be deemed historic, to be on the National Register, and then open to maybe some funding. They're going to want the siding either restored or replaced. Next slide, please. So, you know, we can also kind of think about how the interior, not usually included on maybe a national registration nomination for a residence, but in this case, we're going to say that
yes, it is.
Feeling, the interior is important, and we're seeing that with this fireplace in the parlor. I mean, it's incredible the amount of woodwork and details. The fireplace in the foyer, I'm gonna guess was probably redone in the 1970s-ish. Again, kind of raising that question of integrity. Next slide, please. And so we're going to talk about the public rooms. You know, the parlor, the study, and the dining room are in really great condition and have maintained their integrity. Again, we're seeing that beautiful bay window. Some of the historic features like that curtain rod remain. It's a shame that the windows were replaced, but we kind of get the overall sense of what these rooms were like. Next slide, Sandy, please. And then in kind of specific details of the interior. So we have these sliding pocket doors that are in amazing shape. We have plaster medallions that are in great shape. These definitely contribute to the overall character of the house. Next slide, please, Sandy. And then again, we have some of these interior fixtures like the original gas lamps and the steam radiators. These are important. They help tell, the fact that Pittsford, Vermont had gas is kind of impressive, and I think tells a lot about that community and a lot about this family that they had that hookup. The steam radiators are beautiful. So, as we're moving forward, we're going to have to think about what we do with these features. Maybe they can be left and new heating units can be installed. So we still kind of can read that these fixtures were once there, but they're no longer serviceable. Again, it's going to be a conversation as we move forward. Next slide, please, Sandy. And then we have features that are really interesting. The possibly original tin bathtub and the cisterns, one in the attic and one in the basement. These are very cool. But what do we do with them? Does it make sense? Again, we're thinking about that new level of comfort. A tin bathtub may not meet new standards for comfort. And the cisterns, they're interesting and they kind of tell the story of the need of water and how it was moved around the building. But if they get in the way of insulation or other kind of things, we have to think about their use and how important they are. Next slide, please, Cindy. Yeah, and so here becomes a question of integrity. This is the plaster on the 3rd floor. So we see some roof leaks. So again, it's going to be a question of, is this plaster serviceable? Can it be restored? Is it worth being restored? Anything, you can fix anything, but is it worth it? What is it holding up being there? Do they need this 3rd floor? So these are all questions that we're going to ask, and it's going to be an ongoing conversation between the architect, the builder, the homeowner, and the preservation consultant. Next slide, please, Sandy. Oh, thank you.
So Alex and I met this family, and the big question was, what are we going to do with this house, both in terms of future use and also retrofitting to kind of stabilize it in terms of its energy bills. And bringing in a historic preservation consultant makes sense in the beginning for such a house, because we have to sort through not only questions of its significance for the family and their decisions, but also for possibly getting funding sources. And a preservation consultant's key for helping, especially if the building's not in an historic district already, helping establish that it's a contributing building to Vermont or the region or to the National Register. That's starting to get into the discussion I started earlier. But then there's also this question in terms of the Vermont Energy Code, which we'll get in a little bit towards the end of the day. It's a different bar that one needs to hop over for establishing significance. Basically, it becomes a balance of trying to figure out if the building needs to be exempt in some ways from the energy code, if it's going to be substantially renovated. or can it conform? And so that we have these different levels of understanding the character and its significance to other people. That first group Alex has covered, and then the other set of assessment is the kind of normal things that an architect would do. And many builders or homeowners in Vermont do not employ an architect. So sometimes they might only talk to an historic preservation consultant or only an architect. I feel it helps when we're both working together. But an architect would come and look at this house from a spatial point of view and also the energy point of view. So one of the first things we do is look at the overall site. And we're looking at things such as its southern exposure, how the rooms themselves relate to the sun, the grade it's on, the kind of soil is very, very important, especially as how the building interacts with water and in winter. And one question often is solar going to be an option? As we start evaluating the whole picture of choices, that may or may not be relevant. And solar on the building, solar on the barn that you can see in the back, or ground mounted. Aside from energy retrofitting or use changing functionality of the building, it's super critical to look at structure. So that is really one of the first things I do when I look at a house. And it's interesting, if one brings in the energy rater first, often they are not trained to do that. So they may make suggestions that are not appropriate for the structure of the building. But an architect will go in first and look at, and probably call in an engineer and assess what is the health of the structure, what is the type of the structure. This was probably balloon framed. Is our roof loads being carried down sufficiently? Has shear or horizontal thrust been taken care of? At the foundation level, what is the material? How is it holding up?
Sorry, Sandy, if I could just
Yep.
quickly interrupt and we can go back to that.
Oh,
next
yeah, we have to get to that. Right.
This stencil, penciling of the foundation, you can kind of see the faint outlines that they wanted it to look a little bit fancier with the skim coat, and then they have that red outline of stones. But the field stones underneath have kind of come through over time. That would definitely be a character defining feature if it was in better shape. So again, it's that question of integrity. And again, we see some not so great patches done at the bottom, not matching that historic color of the mortar.
And the architect's looking at this corner of the foundation saying, what is the pattern of failure here? I see cementitious patching, and what's going on? Why is it concentrated in this one area?
Thank you. Sorry.
Oh, yeah. So an architect will look at this hallway and say, these cracks are diagonal. They seem to be in a pattern. I wonder if there's something structural going on. And we'll run around the house and find out that actually the loads upstairs are not sitting on anything downstairs. And so starting to unravel the puzzle of how the structure goes together is super important. They also looking at how things move or fail over time, particularly with flashing. So it's important to know in this dormer, for instance, is it just a weather, a flashing and water issue, or is there something structural going on? It's also important to look at the envelope and to get a sense of what they've done over time. Is it a coherent strategy, or is it kind of piecemeal? And we also, with the envelope, really encourage people to do a blower door test and/or an infrared study. Both are super useful. These highlight the two major issues of an older house. One is air infiltration. And if that can be dealt with, Alex mentioned low-hanging fruit earlier. We'll get into this in more detail this morning, but that is definitely in the category of low-hanging fruit that can help the building function much more like a modern building very quickly. And what's going on in the infrared? That's the question of heat loss. So thermal transmission through the wall. Can be related to air leakage, but it also can be related to simple R and U value, which we won't get into this class, but most people understand that R value is the resistance and U value is the inverse, and U value is used to figure out the assembly of wall. It just works better. We also go through the mechanical systems. This house was kind of fascinating because it the front of the house is heated still with the water, or may even be steam. And the back of the house is an air system. They had a fire in the back of the house, and so they converted to air. And the family was an older woman for many years. She just lived in the back of the house. So it was easier to insulate and to keep warm. Looking at peripheral mechanicals, it's very important to assess the plumbing and the electrical systems of a house. Aside from any of these other considerations, just understanding if they're dangerous. There's not too many lead pipes in Vermont now, but old clogged up pipes and knob and tube wiring. Really, whatever happens, it's good to update. We also measured the building, and this becomes very important with the energy analysis later on to be able to understand surface areas and volumes, so you can begin to quantify the air loss, air changes. We also will typically do a review of all relevant energy codes and building codes. And I guess this is a point here to say that today we're focusing mostly on residential, but small buildings are structurally very similar, small commercials very similar. And then the owners on their own had a heat energy audit. And so this is where we can really see where the path could diverge. If the homeowner is more focused on energy savings than anything else, they could simply follow these directions. But the typical energy audit that one gets is really kind of almost a cookie cutter approach. The technician is following a template, and they're kind of just fitting in pictures of the house and then fitting in the data that they get. They're making suggestions that may be completely wrong for this individual house. You see a picture of totally foaming a wall, an old stone wall, foaming the rim joist. We'll be talking about all of these things. Kind of their approach to the attic, which would be using spray foam and then cellulose on top. It's interesting to look at the sidebar of the cost and the savings, and it's always useful to look at the payback. If it's not a payback of 20 or 30 years, it's probably not as high a priority, and that should be considered too. In the, what is the risk or destruction of historic resources for a limited payback? We're talking about now the bottom here. This suggestion would probably not be supported by historic preservationists, and we'll talk about that more, but completely ripping off the historic outside, which is the face of the building to the public, and possibly replacing it, probably not replacing it in kind. Besides changing the dimensions and the relationship of the window to the outside surface, that we'll be going into this, but please keep that image in mind. Again, I'm on the same page with air leakage, but spray foaming, it may not be helpful. Look, we're talking about recessed lighting. I think most people know that that's not a great idea, or at least get the insulated cans, but the LED pucks. Anyways, so what I'm trying to say is that a one size fits all, that really the goal at the end is to sell the homeowner on this package of incentives, and actually not even a great interest rate to do the work. So this is, we're talking about the difference between one size fits all drive-in meal versus a really delicious slow cooked meal with local foods. And
Sorry, Sandy, just to
yeah.
come in again, I think these energy audits can be really useful to kind of give you a brief overview of, they go through your home with a thermal imaging device, they do the blower door test, so it can really point to the trouble areas that your home or business may have. And then, it gives you some options for how to tackle those issues. But I think really the next step after you identify those problem areas is to then contact either a contractor or a builder or an architect to find a more unique kind of tailor-made solution to reducing your energy usage. And then, think about that risk factor of, what's the payback period? What is the potential damage to historic materials? And, is it necessary? So I think they have their place, but I think you're absolutely right that the tailor-made approach is definitely a better way to go.
I was really glad that the owners called us in to have that conversation. At least then they could make a more educated choice. And I think this is where we've got a few minutes now to talk this over. Clearly, what we're leading up to is this afternoon is going to look at a process of energy analysis and the compromise between the historic fabric of the building and retrofitting it from a more holistic or larger context. And this morning we're going to be talking about the low-hanging fruit, but of how to improve a building. But I would like to talk. So far, have people come up with any questions? And I actually was hoping that Tom or Chuck would chime in about what are the alternatives to a quick energy audit like this.
Sandy, we also have a question from Michelle. And she asked about the storm window, whether there was a storm window that was swinging out from the side shown at the attic level.
Oh, that's a good question. So that is actually a fixed sash. And this is a great example of what we're going to get into later this morning of what do you do about a single pane window in this whole, in the context of the whole house. It's historic. Should it be modified? Can it just be repaired? And so that's one of these small details. The whole plan will be the synthesis of these smaller questions. I'm seeing little things come across the screen, but I'm trying to look at the other.
Lisa had a question about,
Oh.
is there ever an appropriate use of spray foam in an historic structure? And I think we're going to get into that a lot more this afternoon, unless you want to say a few things.
Okay.
If you want to respond to that.
I'll quickly say yes. There's absolutely instances where spray foam can and should be used in historic structures. I think it just needs to come after that conversation and that balance, and looking at that balance of, what's the benefit and what's the risk. I think danger comes when, the spray foam person just shows up and it's what they do. It's the immediate, easiest way to insulate a house and cost-effective way in some instances. So I think the quick answer is yes, there are instances where it can be used. It's about where it can be used appropriately. And if there's preservationists on here that want to fight me over that, I'm happy to take on the fight.
Well, and actually, Alex, rather than a fight, Ron pipes in with a comment that, limited to small air leaks and sealing around foam board may be appropriate. He sort of asked it as a question. Yeah. And I think there are some limited ways of using it in foundations, but not necessarily encasing the entire basement in it.
Yeah, absolutely. Yep. Can foam, I think, is a great material. So foaming around those little edges and those small air leaks, I think that's great. I think it can also be used up against other materials like made plastic or something like that. I'm not sure on the specifics of if it's as useful if it's applied to something like a plastic membrane. But I think, again, let's have the conversation. Thank you, though, Ron.
And Jeff just makes a comment about his approach to stained glass has been to disconnect them from the envelope, vent and drain to the outside, add 2 or 3 pane hinged panel to the inside so that it can be accessed for cleaning.
Yeah, I think that's definitely an option. And think, it's those creative solutions to the problems that I think are best. When we're looking at these windows right here, this seems to me like a prime candidate for either an interior or exterior storm. Whether or not because it's on the 3rd floor, it'd be serviceable to put a storm on the exterior. It's a question. Interior storms, I think are great in that they can be removed if you did want to open a window. This one's fixed, but there's lots of different options out there. So then it's just about kind of thinking about the risks. Like an interior storm doesn't protect the historic window. But just, I think there's lots of different options. Thank you for that.
This is from Bruce. I think the blower door test for the house suggested the air change at 50 pascals was 25 per day. That's just over once per hour, actually kind of tight. Perhaps the leakage was natural leakage, not at 50 pascals. Just looking for a little perspective. And Jay also wants to know what the typical cost of a blower or door test is running these days.
Judy, I can answer that. This is Chuck.
Thank you, Chuck.
The blower door test runs around $400 for the included in the audit. In the new RBs, you are going to need to have a blower door just to determine air exchange. And I think there is just to have somebody come in and do just the blower door test can run anywhere from $200 to $250. But that has not actually, we don't have a statewide list of folks who are on the blower door, but anybody from Efficiency Vermont who is part of their home performance program can do a blower door, but an audit runs around $400.
Okay. Thank you.
Judy, I'm seeing a question about the interior storms and the issue that sometimes pops up with condensation buildup when you have an interior storm. Yeah, I've definitely seen that kind of terrarium effect on the interior. I think adding weep holes just to allow some air movement into that space can help. And then having them be removable so that you can take them off if need be is definitely a great option for that. But it's something, you know, it's one of those things that you need to think about when you're making those decisions.
That's true. Oh yeah, now I'm seeing that one. Thank you. Thank you, Alex.
And I think Rick also has a question.
Yes, I do. I just wanted to make a comment. I've worked with a number of historic homes that myself or my family owns, and we've had the energy audits. And boy, you really have to be careful with them with the cookie cutter. If somebody is coming in and saying, we want to do all or nothing, you know, you got to go out and get the loan and do everything. Be very cautious of that. They need to be able to work with the homeowner to stage it and to be willing to say, you know, maybe this isn't 100% of what we do, but if you can reach 90% for 50% of the cost, let's go with cellulose instead of foam, something like that. So you really need to work with your assessor to be able to pick one that's willing to respect the home and not just make money on it.
That's a really great point, Rick. Thank you for that. You know, so many times I think it's posed as that all or nothing approach. But again, you know, maybe it can be done in phases, and you can kind of find, if you're comfortable, maybe after you insulate the attic and the basement, maybe the walls don't need to be insulated. It doesn't have to be done all at once. That's a really great point. Thank you.
The main question is prioritizing what's the biggest payback for the least amount of work and expenditure. And if they're not willing to do that, find another assessor.
Yeah.
Well, I'd like to jump in here if I may. This is Chuck. It depends on what you want to do with your house. And our program is designed to get a house to net zero energy with the goal of all of us achieving 90% renewable by 2050. If we are serious about taking this challenge of global warming on, I think that is maybe something we might want to educate our clients about. We advocate for the all or nothing program. That's what we go in and do. But we do it in a different way than the energy assessors. We'll go in, look at a building, we'll do the infrared, we'll do the blower door, but then we put together the package for the house that gets it to net zero energy. And if you're going to follow the path to get there, the first part of that path is to weatherize it, to make it as energy efficient as possible. But the program we use, and Tom and I will talk about this more this afternoon, is optimizing that path. What's the best way? What best way to get that? And we have been primarily focused on energy and getting it there through an energy analysis. But I have come to appreciate the older buildings we're in, and there are ways to optimize it without, you know, compromising the historical integrity of a house. So the all or nothing approach is a good one if you want to get to net zero, because you have all the variables that have to be attended to. To say you have to do it all at once is where I would, you know, say I would disagree with that. I'll show you a house later that, you know, it took her 7 years to get to where she was actually net zero. But along the way, she had her house insulated and you know, gained some benefit from doing that. But her goal was to get to net zero, and she followed this path to get there. So yeah, I would say most energy auditors now will give you pieces of the puzzle, mostly the weatherization component, but they never look at the house as a system. And that's where I think you have to be careful when you're taking information from auditors, that they're not looking at the house as a system and how to get there. And participating in this presentation, I'm also now becoming appreciative of the historical components. So we can talk about that later too, though.
I believe Tom Perry, one of our panelists, would like to make a comment.
Yes, I just wanted to add along the line of what Chuck was saying, that the one significant thing about our program, about the Zen program, is that it doesn't rely so heavily on the envelope, so that you have other resources to turn to, which include super efficient mechanicals and include renewable energy. And yes, I mean, those are not always ideal either in terms of their potential intrusion, either on the house, in the house, on the site. But they give you options, more options to work with. And we will be talking about that a lot more later on.
Great, thank you, Tom. Bruce asked a follow-up question to his earlier question because he didn't feel that he quite got the complete answer. Was the rate of 25 AC per day at 50 pascals or imputed using an N factor? I think the question was, how did they arrive at that air exchange?
Well, they must have figured out the volume of the house. I mean, when I've had blower doors, I wasn't part of this energy analysis. So this is done by the owners. So usually we do calculations and figure out what the volume is, and then they Tom and Chuck, correct me if I'm wrong, but they're different readings on the meter where the air is coming through, and you get the rate, so you can tell how much air is going through that machine in an hour, and then you figure out the amount of the air that was in the building, and then you can figure out the proportion. So then you can figure out how many times you would actually, how a day the entire volume would have gone through that exhaust fan.
This is Chuck again. That's a very leaky house at 9,000 CFM 50. So that would be equated to the volume of the house, and then you'd get an air exchange per hour. And then it would be equated to the exposure of the house. So 25 times a day, that's an air exchange of every hour, roughly. So my guess is that would be natural. So I'm not, without knowing the volume, it would be hard to how they came to this calculation. Maybe Tom, are you there? You could help with that one a little bit. 25 times a day.
Yeah, I was going to say the N factor is basically, it's a estimate of natural based on the blower door, which is set at 50 pascals pressure difference negative to the outside. And so it's sort of an estimated number, but I'm guessing that number is based on, that includes that estimated N factor, which was the original question. And I agree with you, Chuck. I mean, it doesn't surprise me that you've got 25 times a day. I mean, that's a little bit under 1 per hour, which I've seen plenty worse than that.
That's pretty bad, though.
You want to do something about it, certainly, if you can.
Yeah.
Okay, good. Well, thank you, everyone, for chiming in on that, and hopefully that was helpful to Bruce.
I think what we should do is take our break now and start up around 9:30. If we've missed any questions,
I just saw that Doug raised his hand. Doug, do you have a question?
Yeah, my only question would be, when you're dealing with a historic building and you're trying to get the retrofits to work, what happens if you can't reach the blower door test numbers? I mean, how do you handle that in trying to maintain just the overall integrity of the history of the building, and yet trying to meet the energy code? And I know we were going to get into it this afternoon, but when does the energy code trump the historic value of a building, and vice versa?
I was going to say, I think there is an awful lot you can do to reduce air leakage. That is a different issue from thermal value, and it's a different issue from vapor transmission, but just air leakage, cracks, crevices, that makes a huge difference in the energy uses and the comfortable use of the house.
Absolutely. My question is, it also retains moisture. And maybe it
Right.
retains moisture in areas that you don't necessarily want to retain moisture. You know, a lot of these older buildings live because they leak.
But there's a difference between leaking and breathing. So that is what we're going to be getting into today. Rich chat, I have to say, I find the chats so confusing when I'm trying to focus on people talking of it. Rick Shappy said something quite important. He was talking about the ACH as a clarification. Maybe people are seeing the notes and so they're kind of able to register them. But if there is anything outstanding for air changes before we take our break, you could raise your hand.
Sandy, if I can just kind of quickly talk to Doug's question. You know, it's a great kind of issue of, yes, once you start sealing up these buildings, you inevitably start kind of locking that moisture in. So then it becomes a question of how are you going to manage moisture coming into the building from the outside and just the interior moisture through, you know, pasta dinners and showers and things like that. So I think it's, again, thinking of that building as a complete system, which is where an architect or somebody really familiar, you know, a mechanical engineer can really help. And I think, you know, just this of seal up your building, you're absolutely right. You can end up with some pretty serious mold issues if you were to do that. I think it's also important to think historically, you know, a colonial house, they say, went through 40 cords of wood a year. That's a lot of drying potential in a small house. So once we remove that drying potential and we start sealing up these buildings, dealing with interior moisture is absolutely important. And then again, you know, it's a question of priorities to your question of when does historic integrity or energy code trump each other? I'm not too familiar on the specific of that answer, but I think, again, it has to come down to priorities of, are you trying to get to zero energy usage, or are you just trying to make it a little bit more comfortable?
And Alex, can the AHJ dictate who trumps who?
That's a great question. Sandy, do you know answer to that?
We're going to get into that a
Yeah,
little
sorry.
later, but so long story short, ultimately it depends on the amount of work you're doing and whether the building qualifies for an exemption, an historic building exemption. So ultimately, it's a matter of proportion. And then if the building is exempt, then it's really subject to what the historic preservation, the division think is, because they're the people that are become leading factors. It's true for historic buildings that are commercial buildings that are being changed especially if they're trying to meet granting. But I think that it's ultimately the builder in this state that has to file the certificate. And so using the resources of Efficiency Vermont, they would make inputs on it, on ultimately how the energy savings, and I mean the air infiltration, the thermal value, and the mechanical systems. Those are the major things that ultimately the builder is signing the certificate saying that the building conforms to the code.
Thank you.
Now we're going to be looking more at general buildings and in looking at a variety of common problems that we see, starting from the bottom up and starting to look at the depth of considerations for making a decision, like should I use closed cell foam here? What are the other options? What are the trade-offs? So let's jump right in, and we're going to start at the bottom of the building. Bob, so we're looking at typical foundation issues that one sees. We've got here a crawl space that is dry laid stone, and it's been leaking so badly that the soils from the outdoors has filtered through to the indoors. There's probably a whole lot of dry rot in here. You can see they've insulated the underside of the floor for comfort. There's a lot of penetrations. I mean, this leakage could be simply due to whatever piping that is. Who knows?
Yeah, let me jump in here. I guess, the focus that I have here is that, before attempting energy retrofits, it's good to have a understanding of the structural systems and doing a review of them so you understand what the impacts you might be making on the structural systems when you start making energy and moisture changes. In some cases, systems may be either on the edge, or they may already be in trouble, and you might make them worse. And this is a case of a stone foundation wall that has been bowing in, and it's got about a 4 or 5 inch bow and a big crack right along that face. And so to go in and try to insulate this now and avoid having some of the heat loss of the building, keeping the soil on the outside from building up frost would probably not be a good thing without making some changes.
Right. So there are 3 major considerations that we're going to be looking throughout the day at all of these different building systems, which is moisture, air, and then the thermal value. Right. So
Right.
One thing that really distinguishes buildings built before World War II and then what is considered modern construction since World War II is reinforced concrete. And so the major difference is that modern walls and kind of what the energy code is built around. Remember, in much of the rest of the country, most of the buildings are relatively recent. Vermont is an exception because we have so many old buildings. That they have reinforced concrete walls, most modern buildings, and these older buildings have no tensile strength. So that is that structural difference that Bob is saying. Yes, you've got to really understand how is the wall functioning after its first 100 years of life is really, really critical. It also goes back to the site issue I mentioned about soil. You need to understand what the soils are on the outside, and sort of what is the whole picture. And this is clearly the walls being asked to form a tensile function, and it can't. And this is where you actually can see daylight through the building. So this is an air issue. It could be a settling issue, right, Bob?
It could be settling, could also be a frost heaving problem, shallow foundation with frost getting underneath it as well. I'm not sure where this one is, but that's what it looks like to me. You've got some moving around. When I look at buildings, we have done retrofit of stone walls. You can find cases where you can make a stone wall work. You can look at the stresses and you can figure out that there is no tensile stress, and you can figure out how to replace in kind with stone. There are some cases where it's pretty obvious that you just need to do a complete replacement, and this happens to have been a concrete wall. And what you're seeing there is the entire wall has caved in and knocked over. And this is a dramatic case to demonstrate that when you take a building and you stop heating it, you can really cause major buildup of frost pressure on the outside of a building.
So these traditional walls, when you do see one that is, I think we're going to see a brick failure next. But
Yeah, this one was one of those things where it's amazing to understand how this could even work. But what happened in this case was a late 1800s building that used to be 5 stories, or I guess it still is 5 stories, but they filled in to create a parking level right up against the building. So those cars on the left there are parked 1 story above the basement level. And so you've got 4 levels of brick landing on a 24-inch brick wall, which used to be an outside wall exposed to the air. Now it's got 10 feet of soil and 4 stories of brick on it. And when I walked into this basement, I was wondering why they piled all those bricks there. And I realized that they didn't pile them there, they fell off the wall. And so you've got this 10-foot brick wall, in some cases down to 1 weight of brick that was left. And this was a case where it was pretty obvious that this wall needed to be replaced.
So if you look at and I think we're going to get into the, actually I'm going to go back. So if we look at these walls, we have to realize that they can't function in tension. And so in this picture, what is the tension? It's the frost pushing inwards, asking the wall to resist it. So how did these last for 100 years without damage, or 200 years? They depend on heat being transmitted through the rock because it's a low R value in heating the soil outside it. And that's even more important when you have a clay soil that's holding water. The other major difference between a pre-modern system and a modern system is damp proofing. So these walls don't have any kind of bitchophane or anything, usually not even a drainage trench on the outside. So that is another question of kind of remediative action that you could take. But that we'll see in a few minutes, that's not necessarily an easy solution either. So often, a lot of the solutions for these involve keeping the soil warm. All right, then we also want to talk about the dry rot issue too.
Yeah, Cindy, there are a couple questions here that maybe I can jump in and try to respond to. Jay says, should we let stone walls in the basement be uninsulated so they keep frost from forming, and then insulate the floor above with rock wool? I think the answer is maybe. There are a lot of different approaches to this. One of the things we have done is just completely avoid addressing issues in the basement. I think if you insulate at the floor, you've got to make sure that there is still some heat in the basement to trickle heat out into the exterior. It is not to say that you can't find a way to insulate the entire wall in a basement. You could take a stone wall. You've really got to look at the wall and understand what what are the issues that are causing the problem or the potential problem, And so one way to deal with that is to excavate on the outside and backfill with a better material. If you backfilling with crushed stone increases the ability for the soil to drain, obviously, and crushed stone also reduces the lateral pressure on a wall. So it's conceivable. It is not always feasible on every building, but if you've got a wall that's thick enough and you can repair the mortar, or maybe it's a loose laid stone, if you can make that more stable by reducing the outside pressure on it, then you could insulate the entire wall. The second question was asked me to speak to non-existent frost walls under an older addition. How could be retrofitted with modern energy efficient walls? I think there are a couple of different approaches. One is to simply replace the wall, if that's an appropriate solution, and put a new concrete or masonry wall underneath the existing building. If we decide that the wall itself, while it's shallow, can be considered stable, you can also insulate, depending on the soil conditions and the depth of below the grade that the wall goes, you can also insulate to try to keep the frost from running underneath underneath an existing foundation. There are ways to do that that meet the building code.
So folks, I think in the interest of time, let's finish these slides and then have this discussion, because I think we're going to see that.
Okay.
So the other problem when excessive moisture gets into the basement is dry rot, which can happen years after the basement is dried out. So one aside to talk about that is addressing the structural damage of the of the floor unders pieces, elements. So here, let's talk about some ways to deal with foundation walls.
Sure. So this is just a couple of examples of ways that we've addressed failing or other issues with existing foundation walls, and so these deal with some of the structural issues and some of the soil and drainage issues, and the insulation isn't shown in these details, but these would be set up into a situation where you could insulate however you wanted to at this point. So this is simply an existing 120-year-old stone wall. It actually happens to be the one in that early photograph. It was a little interesting. It's only 4 feet of stone wall retaining, and it was failing pretty badly. So the solution here was to provide some exterior drainage. There was a lot of water coming off the roof, and pour a new concrete wall inside the basement.
So by doing that, if the rocks and stones are pushed, then the inside walls are holding them in place, right?
Yeah, all the vertical load is still being taken by the stone, and all the lateral horizontal pressure from the soil is taken by the concrete wall. This is a similar case with another wall project that Paul Brun got me involved with several years ago. And this case, this is similar to what we just saw, but we're talking about an 8-foot wall rather than a 4-foot wall. So you can see it ends up being a little bit more concrete, a little bit more work. And there's also no way to get access to the exterior to try to get drainage. So we snuck a little drain pipe between the existing stone wall and the concrete wall. And there's also traffic loads on the outside. So this ends up being a beefier concrete wall to help resist that.
Bob, there's a question. Is that a continuous wall or a pilaster?
That's a continuous wall.
Okay. And Ann is asking, can you talk about examining the exterior of the stone wall foundation without destabilizing the foundation with removal of the soil up against the stone foundation?
Yeah, typically if you're going to look at the exterior wall, you're going to try to do that in sections. You can cause some problems if you start pulling pulling stones out. But usually, if you do one side of the building and not the other, you shouldn't run into too many problems there. It sounds like somebody's had an issue with destabilizing walls during examination and construction. So this is an example of when you come to the conclusion that you're going to replace a wall. What we've done in many cases is reused, taken an old stone wall that has failed and reused, say, a granite facing and put that back into the concrete wall. So you've got a modern concrete wall, and you continue to use the granite. And really, we should have the exterior grade up covering the bottom of the granite.
This is kind of the same, just this is under a porch. When
oh yeah, right. That's the that's the same thing. So same project. Just we left the granite out because it's got a porch that's covering that up. Here's just another example of an existing stone wall. This one was in pretty rough shape and was starting to push in. So we've got the concrete wall on the interior, and in this case, there's also there's just really a 4-inch granite, 4-inch wide by 2-foot deep piece of granite supporting the sill, and the entire granite system and the sill was twisting. So we ended up going back in and putting in a pressure treated wall to get continuous pressure from all the load coming from above to transfer straight down to the foundation. So there are a lot of different conditions that we run into, and every one is different.
I was going to talk about some of my favorite ways of dealing with the issue. Jay White brought up, can we try to protect the integrity of the stone wall? It's kind of an historic resource as well. So I approached, if the wall is in good shape, it can continue to be the primary support for the building. If you have dry soils outside, as Bob said, you can dig down, but if it's clay soil, my experience is that it's really better not to disturb that soil. When you dig a trench on the outside of a stone wall to fill with crushed stone, if it's clay, the clay, it's like a bathtub. It actually draws water towards it and can make the problem worse inside. What I've done is insulate the wall basically from grade above, and then put the skirt out 4 feet out of 2 inches thick polystyrene, and that works very well because then the envelope, if you will, is just kind of continued away from the building, so you have this protected area below that apron so that the frost doesn't begin to push the wall. I was searching for a good material to use to basically to seal the cracks, but also to provide some thermal value. I think open celled foam is the best because it can actually adhere to the material. It is not reversible easily unless you have a lot of time to scrape it off. So the Roxul products would be great because they are both mold resistant. Irene just asked if you could use it for other soils, and Bob, I would say the answer is yes, right? You could do that for other soils. It's just a sandy soil is draining water away from already. So, but if you're trying to deal with the insulative values so that you could see the rock, the stones on the inside, yeah, of course you could use the apron. But I was at the question of Roxul versus other materials. The hard problem about Roxul is that it doesn't attach itself. So you could use some kind of caulk, but that doesn't work around stone because it won't adhere. So I think the cleaning it and then adding a spray is, for me, has been the best. There's no clear, great answer here. The other thing is that if you do slow transmission of vapor, so the other thing that's important to remember is that masonry structures really depend on breathing out on every surface. That stone assembly is drawing up moisture, wicking it up, just because of the pulling action of dry air. It's pulling moisture through the rocks, up through the granite sill beam that you're seeing there, or sill blocks that you see there, up into the timber frame. And unlike a oops, see, it's coming up this way. Unlike a masonry structure that continues to be masonry up through the building, they have a water table so they can dry vertically. And that's what a water table is all about, is keeping damp out of a building. And it does a tremendous job of vertical aspiration, I guess, just breathing up vertically, because partly because the sun is hitting it and partly because it's going up. But to return to this picture, once you start to seal anything on the inside, it puts a lot more pressure on the upward drying surface, which is the sill beam. And if you were to make the mistake of sealing the inside of the what we would call a rim joist there, but it's really the sill beam, you could rot that beam. And I have seen, I just don't have a good picture of it, that these beams have lasted 200 years, but then all of a sudden, I'm agreeing about that with the moisture. So if all of a sudden, after 200 years of being completely hard and dry, that sill beam will start to rot. So that again is in the trade-offs that you have to consider. It may not be wise insulating that. Maybe it's better just to try to deal with the air leakage. So in this one, you can see the picture on the left, we started insulating right at the top of the stone wall. Only the height of the granite block, and then actually put tar paper up at the bottom of the sill beam to avoid the spray from going up over.
Sandy, I just have a quick question. Would adding something, slowly jacking the building up and adding something like sill seal between that granite and the sill plate, would that stop that? I think would stop that kind of diffusion of moisture up into the sill, right?
Wait, that is beyond anything we've ever considered. Jacking the building in order to get sill seal there. Bob, I mean, it seems like that would be a great idea, but that's a lot of work. I guess if the building's worth it, right? And the budget allows.
Yeah.
This is Rick Kirshner. I think all of this is getting to the first thing. The first priority with historic buildings is getting the water away from the outside. And that's what we're all saying here. Before you even start any type of insulation inside, if you don't have gutters on, get gutters, and don't dump the gutters right at the base of the building, but get it away from the outside.
Absolutely. Which happens to be the next part of this, which is that a traditional building, when these buildings were created, often they had decent slopes away from the building, but especially in an urban situation, grade tends to grow up over time. I live in downtown Montpelier, and the grade is 6 feet higher now than it was when my house was built. And that can easily create a situation where groundwater is running towards the house. And as Richard was just pointing out, the eave line dripping can be a major issue. And so dealing with water at the surface level is really critical. One detail I've been working on, and I think part of this whole session is to start a forum for trading ideas between practitioners about how they've dealt with this issue. So this is another situation with clay soil that should not be disturbed, and it has this apron. What I tried doing was putting a 5-inch thick reinforced slab from the wall out, safe distance away from the house, I think it's like 8 or 10 feet, so that the drip line water, because especially with clay soil, what happens is the drip line gets deeper and deeper over time, and the problem is just gets more and more impossible to fix, because again, it just begins to, really becomes a sinkhole, which eventually finds the basement. So making a concrete skirt on top of the insulating skirt can be one solution. It needs to pitch to drain. It helps to have some kind of pavers or something over it to keep the stones intact as a drainage system. And then getting it kind of far enough away from the house that it's not likely to go back, and then try to trench it to daylight can be, that this is just one idea. All right. Inside, either as a belt and suspenders approach if other actions have been taken, or it may be a primary action. One thing I've tried to do is to put a bed of stone underneath a new slab. So it might even mean taking out an old slab or excavating down further, and putting in flat perforated pipes that would lead to a sump pump. So this is another way to deal with it. Someone was asking earlier about mold, and so part of the problem, you can remediate after the source of moisture is dealt with and the moisture levels reduced. But dry rot will continue even after the building's dried out. And here, I'm just going to finish these and then we can have this discussion. So, I mean, my experience is, Bob, I've been very politely quiet. You could speak up, but it seems that you've got to deal with the structural, I mean, the whole building is at risk if you don't deal with rot, and you can treat it with borates. My experiences is better just to start sistering on and kind of deal with the issue before any new wiring and ducting and plumbing is added to the building. But the dry rot is a really serious problem.
Yeah, let me add my 2 cents on moisture and rot. Typically, obviously one of the things you need to be careful about as you do an energy retrofit, if you're trying to cut down on air movement through your building, if you've got a moisture problem in the basement, you're going to make your moisture problem worse. So Jeff is absolutely right. You need to go and deal with a vapor barrier in the basement, and also through the exterior walls, the basement floor and the walls. The rot in wood. Basically rot is a fungus which requires food, air, and food, oxygen, and water. And so you need the food is the wood. And so if you have your moisture content at the right spot, then you're going to start to get the deterioration of the wood. And so if you do drop the moisture content of the air down far enough, the rot will stop. It won't grow anymore. You obviously still have the dry rot that's left over, but you can halt the process of rot by removing the moisture content. So so when you go in and reinforce, as Sandy was talking about, you'll have you need to have the moisture drop down or be reinforcing with pressure treated. So that's just my 2 cents on some of the moisture issues.
And I did forget to say that. Thanks for the reminder that probably everybody in this conference knows this, is if you don't have a vapor barrier on the floor, and there are a lot of houses even built in the 60s that have no vapor barrier underneath a concrete slab, that is a really hard thing to do. So much moisture comes into a building through the floor, even in sandy soil buildings. And it's almost easier to be starting with a dirt floor, because then you can pull some dirt out either by hand or machine and make the slab, as I showed, with something a really good barrier underneath, like Stego wrap. But if you have a slab, I still don't know of a great solution for getting, other than pouring a second slab on top of it, for getting something that is really mold free and performs well.
There's some buildings that have really, you resort to a dehumidifier, and you do the best you can by pulling the moisture out mechanically.
I just want to quickly comment on that earlier question of the historic integrity of these walls when you're pouring concrete up against them. Sandy kind of touched on it, but these are walls like that picture that I put up of the plaster all on the ground. These are walls that have arguably lost their historic integrity because they're failing. And so then, we kind of make that risk assessment of, is it worth it to save these or to cover them up and then kind of have still the exterior of the stone. So I think it's just something to kind of think about. Again, we have to assess the materials that we're working with and whether they retain their historic integrity.
Alex, that's a really good point. And because at some points we get to a moment when it's the treatment of last resort.
Yeah.
Before you would be removing the historic fabric. And I think sometimes the idea of adding these materials has more to do with the notion that addition is better than subtraction, because then you can track the changes that have occurred over time in the building. Yeah. There are a few that have come in here, or maybe even a few comments. Jeff is noting that he's found that heat pump hot water heater in the basement helps greatly with dehumidifying, and the energy use goes to purpose rather than using energy for a standalone dehumidifier. Jay talks about being aware of a major problem at a building where they were told to remove a stone wall to be able to insulate and replace it with a new concrete foundation. A problem with 100% clay soil, now trapping water in the crawl space that used to drain through the dry stone foundation. I'll just end that with, I think we're all looking at a cautionary tale here, and I think that Rick is right. The first thing we have to do is make sure we are drying the building out as much as we possibly can.
Yeah, I think I would add that I think with all these cases, they're all a little different, and you need to look at them holistically. And it's all these different things. And so I agree with Jay's closing comment. I think insulating stone foundations is dangerous, but it's not impossible if you think through all the factors that go into it and understand what you've got for soil conditions and water conditions and air movement conditions.
So, other end of the building, another place you tend to find structural calamities quietly hiding away is the attic. So, Bob.
Yeah, I guess the biggest thing about the attics and the roof structure is that whenever you add insulation to a building that's in use, you're potentially reducing the amount of heat loss, obviously, and therefore you're reducing the amount of snow melt, and you end up increasing your snow load on your roof. So you do need to be cognizant of what you're doing when you're adding insulation to an attic. You need to be careful about overloading your roof system. So the building code doesn't specifically come out and say it unless you cross a threshold through an R30. When you cross that threshold from below an R30 to above an R30, technically you do have a change in roof loading conditions that requires you to look at something. The state of Vermont, my experience has been that the code officials will tell you that you need to be doing a roof analysis if you're adding insulation to an attic. The other thing I would point out too is you need to be careful about cutting off your ventilation systems. I looked at a building years ago where just this type of thing, they added 12 inches of blown-in insulation and covered up the top of a balloon wall system, and a lot of moisture in the basement. And over the years, the moisture had been what we found out was the moisture had been ventilating out of the basement through the exterior walls where there was no insulation. So there was a direct path of moisture out of the basement through the walls into the attic and out through all the cracks. And as soon as they added 12 inches of blown in, they capped that, and all of a sudden they couldn't keep paint on the building anymore, because all the moisture was going up through the walls and was blowing the paint right off the face.
Oh, here's a cautionary tale. One of the interesting things about where if a basement has a somewhat different temperature grade, it's a lower temperature gradation between outside and inside until it comes out of the soil. The roof is probably the place that's most important. There's going to be most payback for insulating. So the R value thermal question becomes much more important up in the roof, in the debate about weatherization and the debate about net zero energy. There is quite a bit of pressure. Often attics were not used, so they can or might not have as much historic value. It's a kind of different debate from the other parts of the house. But here are some of the structural failures that are important to look for in the background of in any case. One would be, here are pole rafters that are probably undersized and too far apart, right?
That's right.
And then we're going to talk about this one.
Okay, it looks like, yeah, hips and valleys are typically the weak spots in a building, especially residential buildings. This is something that we see in a lot of residential buildings too, where the collar ties are high and you have a knee wall that doesn't allow you to tie the floor across at the bottom of the rafters. So you get a lot of spreading and bowing and sagging of the roof, and by adding insulation to that will make that system worse. Sorry, I'm not sure what that one is, Sandy.
Just starting to come away. The first one is spreading. The roof is spreading.
Yeah. Okay.
And then here's another example. Well, that's what you're talking about.
Yeah, that's a a lot of post and beam systems. This happens to be a barn, but you'll see a little bit different but similar type of trusses in town halls and churches and those types of buildings where the truss systems are losing their integrity at the exterior, and there's blowing out of the roof trying to spread and failing the mortise and tenon joint. In this case, they've added cable ties to hold the building back in.
So if we're trying to think about the two basic ways of insulating a roof, one would be, and again, because of the payback, I can't think of Vermont of a case where there's a decision to not insulate the roof or ceiling at all. Maybe at Shelburne Museum there may be some examples, but I think that this is a case where people accept that cultural changes have been so significant over time. we heat our spaces more, we wear less clothing, we we create more moisture with less ventilation for it to get out of the building. So the thermal value is critical to not have a huge amount of air movement through the house, as well as to just to keep the heat loss down. So the attic floor is one scenario. Many of these roofs breathe both out through the roof structure. Quite often you see board sheathing, some kind of wood shingle underneath, and then often gaps, like ventilated roofs before other layers of asphalt. On the other hand, sometimes the shingles were removed and it's already not breathing out, so it becomes important to be able for it to be to breathe inwards. That but as long as these are kept ventilated, one side or the other, there's no need to insulate the rafters themselves, which is good because then that helps reduce the load on the roof. This is also kind of reducing the surface area that has to be insulated. In other words, less material. And it's when you use cellulose, it is reversible. A lot of people will put some spray foam on the underside of the roof is to deal with the vapor retarding question, which we're going to get into a little bit more later. But this is a kind of standby solution, particularly when the attic's not being used. So this, there's two pictures here together. The alternative would be to usually reinforce the rafters and then install some kind of batt or foam in the bays, and it would be with or without a vapor barrier. Often, if the building can breathe outwards through the roof of materials, then you could actually put a layer of continuous insulation in. Thermax is a common one, so that the vapor barrier is all sealed in, kind of continuous, and it's on the winter warm side. It makes a nice, actually it's reversible if you use bats and Thermax. It makes a nice assembly that lets people have ventilation and heating ducts in the space up there. It lets the space be converted to use. But there's going to be pluses and minuses with either approach. I want to go right into walls. And the interesting thing, so foundations are one set of questions, roofs are another set of questions, again, with these same variables of air, moisture, and thermal resistance. Walls are really important for the defining character of the building. From the outside, they define the object, and from the inside, they define the space. So they often have relatively heavy importance in preservation. They also, interestingly enough, contribute less to heat loss for the whole building than the roof. So partly because heat goes up, so rises. So there are some more solutions. It's not quite as urgent to add thermal resistance in the walls. It's getting more common to strip off the entire outside of the building. That's what happened recently at North Branch Nature Center in Montpelier. And you can see in the process, a lot of things changed in this building. So the windows are in it, everything's moved out. The trim has been changed. It's not the same. And they had already been changed. So one could say that it was not significant anymore to begin with. But the bay window, which unfortunately is kind of covered by trees, it's hard to photograph, looks very different now. So this is not an approach I would normally recommend to a client. And another approach is to strip the inside. These pair of photographs was shared by John Alden, and it really is just sad to strip off and probably not be able to put this back. It's possible that they were going to put it back, but often what happens is pieces get lost and it never returns to its original appearance. So one solution, and you would want to be very careful of knowing if the building is a balloon frame before you would think about doing this, but would be, and if it is, to think it through. But one solution is to insulate just in the bays by going through the outside of the wall. And as you can see, there's some damage, but it is relatively minimal damage replacing the siding after the holes have been drilled. It should be done in connection with infrared to be able to make sure all the voids are filled. I wanted to say a word about masonry buildings and some wood buildings. For instance, I live in a house that is solid wood. There are plates of wood stacked up vertically, and the walls have to breathe from both sides. In masonry structures often also. If that is the case, it is probably best to look for insulative value elsewhere. And if one needs to go through the process of exemption from energy codes, talking about its historic significance, these buildings are now so rare and so local in their manufacture, how they were built with local stones quarries, and even if they're not in an historic district, I would think they'd be able to make a case that they're significant structures. Oh, this is a picture of my own house. And so remember, I mentioned the solid wood walls, and there's a structural problem happening here at the stairwell opening. And so something like this needs obviously to be examined before one went further with any weatherization decisions. The plaster could probably be repaired, but if the cause of the damage isn't solved, then it would just become a problem again. And in my case, this is historic wallpaper, so it's a very complicated issue of how it would be fixed. Also looking carefully at the structure for sources of rot in the superstructure, as we call it, the frame. I want to transition to this question of air. So we've had a lot of discussions about the amount of air leakage and what is healthy and what's unhealthy. Again, it depends on the building. If a building is quite leaky, and it's able to breathe, breathing is through the particles and pieces of a wall assembly, whereas air leakage is coming from a hole, a path. It often is good to seal cracks, for instance, between a baseboard, because there might be air coming from either from the basement or from outside at the connection between the floor the sill beams and the wall structure. So you would get both sides of the baseboard. This is just one small example. And unfortunately, this was done after all the finishes were applied. So the caulk is gross and invisible, but it does make it possible to use as an illustration. Infrared is super helpful for seeing where air leakage is evident. And so this is a wall outlet. And so a couple things to think about with a traditional wall structure. There were so many openings in other places that air was typically not forced through strong pathways in the wall itself. The wall would be under relatively less specific pressure in one place. If you were to seal up a whole house and leave one hole like this outlet, and then turn on an exhaust fan that's not balanced with an air intake, you would create a vacuum in your house, and it would pull. If there were nowhere else to pull, it's kind of if you blow up a plastic bag and then it can only escape out through the neck of the bag until it pops. That puts a whole lot of pressure on this outlet, and that would definitely encourage mold and moisture buildup, because if it gets wet to the point of saturation and then cannot dry out relatively quickly, so if it's staying moist more than it's drying, then that would be a likely spot to find mold. So an older house would not have been built with electrical outlets in the outside wall. One solution, which strongly encourages using floor outlets in older buildings rather than trying to add outlets onto an outside wall. But if someone has done that already, you could either remove and patch, or at the very least seal that up so that you're closing off that pathway. So as people have mentioned earlier, you don't want to close off all pathways, because then the moisture levels will build up. But and certainly balancing the air pressure becomes more and more important. But this really is a large overall strategy to be developed before one starts. Looking at areas where there is moisture, it's again important to know if there's something behind the problem. Is there flashing that's failed up above? And then coming up with a solution. We wanted to talk briefly about all of the many plaster solutions, such as, well, they're a little bit harder on ceilings than walls just because of gravity. But this room with the cove ceiling has had repaired plaster both on the wall and the ceiling. It got stripped down. There are many kinds of repairs for plaster, from washers to lime plaster putty. If it's started to delaminate, it can be attached back on. I would say as a last resort, you would take it off and add sheetrock. And then this room actually had sheetrock added on the ceiling because the plaster ceiling had failed so badly. And so a ½ inch of sheetrock was added on and then skim coated before being painted.
Hello, and welcome to Repairing and Replacing Windows. I'm Judy Hayward. I've been the moderator for today's workshop, and I'm going to spend the next few minutes talking about repairing windows, replacing windows, and sometimes when we do both on the same project. Why repair? There's a lot of embodied carbon in the wood in windows, as well as in the manufacture of the glass that we find in windows as well. And in addition to that, most of the windows made in America before 1940 are made of what is called old growth wood. Windows from the 18th and 19th century are often taken from wood that came from forests that had grown very slowly over centuries. It was very dense. And when wood is allowed to grow slowly, it develops superior decay resistance. And it's one of the reasons that we still have so many old wooden windows around, despite a lack of routine maintenance. Other considerations in repair are that windows contribute greatly to the character of buildings. And we'll talk a little bit more about that in another couple of slides. But just quickly, if you take a look at the window in front of you, this is taken from a Queen Anne house, and you'll see that the upper sash features muntins in a very decorative pattern. There's a diamond in the center, flanked by 4 sides, and the lower sash is just a single individual pane of glass. And if we were to remove this window and replace it with a simple 1/1 window, we'd lose a lot of character in the building. This window also has a nice detail at the base of the upper sash. You'll notice the decoration underneath the meeting rail. And this kind of decoration gives subtle play of light, it gives shadow to a window, and all of these distinctive features really contribute to what we call character. And we'll talk a bit more about character in a few minutes. Prior to really the 20th century, most of our windows are handmade, or they are crafted through early machines that documented changes in sash making technology. So there is a handcraft tradition, and they are often seen as good evidence of our industrial heritage. Glass prior to 1900 is either crown glass, which is brilliant in appearance but has greater distortion, or blown glass, which has less distortion and still some waviness. After, or right around 1900, the process of glass making becomes highly mechanized, and it is what ushers in the era of plate glass and other types of ornamental glass that we have been able to benefit from during the 20th century. And the other consideration about repair is that the energy loss through windows is estimated to be about 10 to 15% of the total loss of a building. And the question here is, will you get much of a return if you were to replace those windows on energy savings? Additional considerations about repair. A good resource is Preservation Brief number 9, written by the National Park Service. And it discusses 3 grades of repair, grades 1, 2, and 3. Grade 1 really addresses minimal repairs like redoing the putty, painting the window, just keeping it in good shape. A grade 2 is a selective replacement of elements, missing parts, missing glass. Again, not too much, but somewhat. And then the grade 3 is really the significant replacement of missing features, such as entire sections of the sash, the meeting rails, the stiles, and sistering in new wood in many, many instances. It's important to note that whenever we work on historic windows that have paint on them and the painting was done prior to 1978 and maybe even a few years after, that we need to be concerned about lead-based paint and always follow lead-safe work procedures when working on historic windows. And it's important to do testing to document what you're working on. Another consideration gets back to the glass. If you are working with existing sash, some craftspeople have removed some of the building fabric and have been able to insert double or even triple glazing into into the glass, and that can work, but you often do remove quite a bit of historic fabric, and it will have a change in the appearance of the building. There have been challenges with double glazing. There have been problems over the years of the gas that is within the double glazing failing because the seals or exiting the glass because the seals failed. There's also vacuum insulated glass, which is sealed a bit differently and offers some promise for longer life. And it also has a superior R value in many instances. The value of vacuum insulated glass is that it can also be manufactured to a thickness of 1/8 of an inch, and that is often very helpful when you're replacing glass in historic sash. It will work well within the existing historic sash. It's important to also remember that when we repair a window, we're preserving the maintenance cycle, and it keeps the resource in use in situ. It's also important to think about windows both at a distance and at close range. The Old South Church in Windsor, Vermont, has a very interesting window or fenestration pattern. You can see that there are 5 bays on the side elevation, and there's a difference between the windows on the upper story and the lower story. But there is symmetry, and these windows do contribute to the historic fabric and our understanding of the building. The building was built in the 18th century, but it has undergone several significant repairs. And the window that we see in the close-up here is dates from about 1922, when the building was returned to the understanding of the congregation at that time of its 18th century appearance. The windows had been altered significantly during the 19th century. But if we take a good look at these colonial revival windows, we see that they are really beautifully made. They're large. They have a beautiful window casing with a stepped molding and a beautiful lintel over the top. And not only are these details beautiful, but that stepped up molding in the lintel at the top really helps this window shed water. So the person who crafted this had a really good understanding of how to help wood perform well in our climate where we have frequent rain and snow. So sometimes the beauty is really about function, or they work together and in concert. And that's an important consideration when you're thinking about repairing versus replacing. If you can preserve craft detailing like this, it's important to do so because we are supporting the long life of materials. And again, that's good for reducing the carbon footprint of building materials. It's important when we undertake a window project to assess the condition. And it's pretty handy now with a computer and an Excel spreadsheet to develop an alphanumeric code that we can assign to each window. So it improves communication on the job site. And it's great to document the condition of each window so you can help with writing specifications for the work and or help communicate with the craftsperson who's going to be doing the work. And you might want to use a rating system for the repairs, and using the grades 1 and 3 that I discussed earlier from Preservation Brief 9 is a good recommended option for doing that and for communicating in a way that is understood in the preservation construction community. In addition, you're going to assess the character, and some of the things you should look at include the original details and or significant changes in window design over time. Just like I showed you an example of 1922 windows in the church that dates from the 18th century. They're still significant, they're still important. Some of the things you're going to want to examine are the muntin profiles, the casings, the lintels, the sills, and the reflective qualities of the glass. A good resource for helping you assess character is another National Park Service preservation brief. It's number 17, and it's great not only for windows, but for looking at the entire character of a building, both inside and out, and helping you make the decision about what is significant, what is important, what is worth preserving. Well, while we always recommend repair as our first treatment preference, there are times when we're going to need to replace windows. The obvious time is when the windows are missing. And if that's the case, researching what the historic windows look like will help you match the historic configuration if possible. You may have to work with several different periods because there may have been more than one generation of windows. And again, you're going to want to consider the size of the window, the numbers of panes or lights of glass, Muntin profiles, and shadow lines. Another question you should ask yourself is, are you replacing earlier replacement windows that have failed? And one of the reasons to ask yourself that is it's good to determine why these windows have failed and document that, because that will inform the things you want to find in a new window if you're going to have to replace a window or fill an opening that doesn't have a window in it. Try to determine what might have caused failure in the first place. Is it a situation that you can correct moving forward? Is it possible to repair some windows and replace others? Replacement may be an option in or outside historic districts on non-primary facades or even on upper stories of primary facades. And it's good to talk with your preservation commission before any work is done on a project, whether it's windows or other elements, so that you learn what their expectations are for protection of historic fabric before anything gets removed. Why replace? Comfort is often a big factor. There's often the feeling of draftiness around historic windows, and that often has to do with sealing the perimeter of the window. Oftentimes you can put insulation around the perimeter of the window and really reduce the sense of draftiness. Reducing the number of maintenance cycles is another consideration in the repair versus replacement continuum and discussion. Sometimes on a large commercial building or a big industrial historic building, it may be difficult to reach upper stories and expensive. So reducing the number of maintenance cycles may be a legitimate concern on the part of an owner. And again, knowing what is permitted in your local preservation commission, if you're working in a historic tax credit project, working with the state preservation office so that they can review your project with the National Park Service in advance of any work being done, so you know what the parameters are. That's very, very important, because sometimes a hybrid approach can be undertaken on jobs where certain key windows, particularly those that are readily seen by pedestrians, can be restored, and that other windows might be able to be replaced to help with this balance on costing out maintenance cycles versus the repair cycle. But you must remember that once you enter into a replacement cycle, windows will need to be replaced, depending upon their warranties, depending on how they actually perform in situ. But you're probably looking at replacing every 20 to 50 years, maybe a little more, maybe less. But how will those windows be disposed of? And are we just adding to waste when we get into that replacement cycle? Important questions to ask. If you're restoring a window, the thermal efficiency can be greatly improved with storm windows. An exterior storm does a great job of protecting the primary window. An interior storm is likely to give you better heat retention and, again, perhaps a better sense of comfort, but no protection for the exterior of the window. Regardless of which system you use, be sure you have weep holes, because you need to allow vapor to move through the window. They've got to be able to breathe. And because of differences between inside temperature and outside temperature, condensation is going to be an issue, and the weep holes will help you manage that. Finally, while historians talk about architectural character and we all want to save energy, it's important to ask ourselves, how does science inform this discussion? Vermont was a pioneer in examining windows and the importance of storm windows as early as the 1990s. The Vermont Division for Historic Preservation worked with the Cold Regions Lab in Hanover, New Hampshire, and that's a program of the Army Corps of Engineers, and they developed a study with funding from the National Center for Preservation Technology and Training. You can still get that study today, and you just really need to update it with contemporary cost information. It's still really good, and it documented that windows that are restored with a storm window are competitive with replacement windows. There have been at least 3 studies in the 21st century that I know of. The National Trust worked with the Preservation Green Lab at Berkeley in California and tested windows and produced similar results. Frank Shirley, an architect in Cambridge, Mass., undertook a study where he compared window restoration with a vinyl replacement window and found that restoration could be cost competitive with a vinyl replacement window. And the Window Preservation Standards Collaborative is a group of craftspeople, building craftspeople, who have published guidelines on how to repair windows and have done some testing to back up their work, and they've come up with similar results, that it is both competitive in terms of cost and energy conservation with replacement windows. My hope here is that I've given you some insight into the value of repairing first, replacing in kind when you need to make repairs, and also an understanding that there are situations where replacement windows are in fact accommodated in the historic preservation world. And I hope that this is helpful to you with your projects. And I would encourage you to certainly reach out to me. I can help you locate craftspeople who are willing to do window restoration work and point you in the direction of some of these specific studies. So thank you for your time today, and I appreciate your patience in listening.
As Judy said, historic windows can be comparable to new windows in efficiency, but that just takes some effort. Historic windows are designed to be infinitely repairable, and each part of the window plays a role in the efficiency of that window. You know, for example, when we look at the sides of historic windows and we see those pieces of trim, sometimes with screws and washers, those are called the window stops, and they're designed to be moved in and out, tight to the sash in the winter to stop air movement, and loosened in the summer to allow the sash to move freely. We often see these details painted over, but just with a little bit of work, they can be brought back into service quite easily. Another just quick window detail is that meeting rail and the lock. When that lock, is in place, it brings those 2 sashes together to form a tight seal. Ensuring that the lock works properly and installing weather stripping can greatly increase the efficiency of your windows. And the same is true with doors. Weather stripping and things like that can greatly increase the efficiency. And so this door here, we see has a storm door, and like windows, really can be a great energy saver. Again, like windows, we can add double pane glass to doors to increase the efficiency. And it's important to note that the difference between your energy savings with the historic door and a modern door are not that great. Sometimes modern doors have a layer of foam in there, but that's really not saving you that much. Similar with the lock on a window, the striker and the striker plate on a door can be moved in and out and can be adjusted to form a tight seal. We really want that door shutting properly and pulling that door into the weather stripping. And we can adjust that based on the weather. Another kind of quick fix are those letterbox holes that we see in door cores. Sometimes, we can definitely leave them in place and just add a little piece of foam and maybe some wood veneer on the interior, or they can be removed entirely and just like a Dutchman patch to fill it in if you're going to paint it. Again, similar to windows, weather stripping and door stops can do a great deal of help to increase the efficiency. We can move those stops in and out to form that tight seal to the door. and weather stripping down the threshold is again, a cheap and easy fix. Again, I think we need to think about these both doors and windows in that they were made to be efficient. They were made to really be airtight. So as you're looking at a window and you're looking at the window stops on either side, some of them have little screws and buttons. Those were made to come in and out depending on the season. Out on the summer so you can raise and close windows, and then push them in the winter so that they form that tight seal against the sash. Window locks especially, yes, they're great for security, but they're also perfect for making sure those meeting rails in between the two double hung sash form that tight connection. And there's a number of different types of weather stripping that I can't go into today that can really help form that tight seal in between those windows. And then you're left with an interior or exterior storm. So just before you kind of, again, I think before you kind of jump on that replacement train, think about different steps that you can take with the existing windows to button them up. There's again, so many different ways to do it. And just to kind of quickly go over some of the questions that I saw come in the comments. I'm not sure preservationists have a particular preference for interior, exterior. Interiors are great because I think they're much, I'd have to assume that they're more cost effective and that it's just a sheet of plexi that you can kind of put into the opening and remove as need be. They're definitely more user friendly. But they do have, they don't protect the sash against the elements on the exterior. So that's something to take into consideration. Exterior storms, wood exterior storms, our triple tracks are great, but they do kind of change the appearance of the exterior. And whether or not you can remove them, do you need a ladder to remove them, are all things to really consider.
Can I add a couple things?
Yeah.
One is that I've done in my own house wood storm windows that are fixed glass in the upper half and then exchangeable from indoors between a storm and a screen can work really well. They only need to be removed then for painting and insulating. Someone was also asking about storms both in and out, and it just the need for air is important. So it's not, the window's not kind of, you used the word terrarium before. If the storm window is completely sealed in there from both sides, then that's not great if some condensation gets in.
Yeah, I would definitely worry about air being, or moisture being trapped inside. But they can be mitigated and through weep holes are just through kind of opening them up temporarily. So yeah, it's an interesting question, kind of creating.
The other thing that responding to someone's question is, in my mind, the issue all over the vertical surfaces of a building, so windows are included in that, air infiltration control is more important than thermal value. The payback is very long. In other words, little for adding a lot of thermal resistance in a window. So going from double to triple pane is a long payback. When one's trying to achieve something like a passive house certification with an historic building, that becomes a very difficult issue. And maybe I think that you could begin to look at both interior and exterior storms on the historic fabric as a way to do that. But I think we need to hold that discussion really until later, when Chuck and Tom are talking about the whole picture of getting to net zero energy, because that may not be a wise decision if there are other ways to achieve net zero.
Sandy and Alex, I also thought of one thing that I wanted to mention. There are an infinite number of ways to weather strip windows. And what I have found with most contractors and tradespeople are that each has their own preference. And I think that, like I say, there are a number of things that will work well. Sally Frischburn is our primary instructor, and for window workshops at the Preservation Institute, she has a strong preference for bronze. And that's a good, durable, traditional material. Others have just different approaches to how they want to handle that. And I think you can work that out with your individual builder or artisan.
So fireplaces in many old houses in Vermont, and a source of a lot of problems, but also a lot of character. It can have faulty pointing, even spalling in the exposed part of the brick. They can have faulty dampers. They can actually be fire hazards if wood in the hearth have changed such that embers can get down between the firebox and the hearth. There was a house in Montpelier that had a serious fire due to that just a few years ago. Some people really want to retain that fire option, and so whereas putting an insert in where it can easily have a dedicated air intake and a smaller flue being fit up inside the original masonry flue is, I think, a very good option. It's sealed combustion this way, but can completely heat a house. There are, these are just grabbed offline because I know that theoretically you can retrofit a historic fireplace to have a dedicated air intake. Why is this important? And why is this important even with the 1970s wood stoves that I visited at a house last week? Fire combustion, open combustion like that takes a huge amount of intake air. And when houses were drafty and people just basically wore their outdoor clothes inside all winter, that was fine. But for now, we keep turning up the thermostat, and it doesn't make sense. It demands too much of the building, especially when we start air sealing. So for any of the mechanical things that we're going to talk about in the next few minutes, it becomes more and more important to have dedicated air intake for that appliance or fire. And it is possible to retrofit the stoves, or if for some reason you're having to rebuild the firebox anyway, it gets very easy to add one in. Other areas that can be real problems, older exhaust fans, there could easily be replaced with a Panasonic and then put on a cycle. This is a Lunos, which I'm about to try in a new project. It's called the Ego, and it's actually, I don't know if it's an ERV or HRV, through the wall unit that doubles as a bathroom fan. So I guess this is going to be the next generation of actually capturing the heat as it leaves the moist air of a bathroom. Range hoods. This kitchen actually has a range hood, and you can't see it hidden. Most people don't mind seeing them, but the important issue is that they need air intake, a dedicated air intake, if at all possible, somewhere around the stove. Otherwise, you can design air intakes in other parts of the building. I just realized I forgot a slide I wanted to show. There's something called a passive air inlet. It's a sleeve that you put in through the rim joist, usually into the basement. You undercut the basement door, and then the air can circulate it up into the house. Panasonic makes those, other companies do too. So it's a one-way air inlet, and so that's completely fine. It's a intentional hole in the wall that is one-way valve, so that when something is drawing, it goes through into a utility room, tempers and then comes up through the building. If you have a ventilation system in the building, you don't need that. The mechanical system itself can pressure balance. But a range hood that is not balanced with air intake can really, really cause problems, just like those 1970 fireplaces of creating a tremendous amount of condensation, particularly on windows, and doing a lot of damage. I wanted to get to the energy codes. I think what we're going to do is talk about that more at the very end of the day, but they are kind of the standard which everything needs to be measured against when you're doing work on a house in Vermont or a commercial building. Judy, have you got a log of questions?
I do actually. We've got some really good ones for follow-up to windows and doors. And one of the questions that came in both from Kevin and John was the whole issue of dealing with egress windows. And, how do you make them efficient? Because you really can't put a storm on them. Sandy, I think I noticed in one of your slides, you had an egress window that looked like a double hung that was swinging outward. Was that right?
Do you want me to go back to it? I did.
That'd be great if you can do that.
This is an owner's apartment above a store, and it was completely renovated project. And yes, so we, one of the things that we didn't talk about so far with the decision about windows and doors is the hierarchy, that sometimes the street facing windows might be dealt with differently from the back. And that can give homeowners latitude for both a couple things, meeting the energy code, but also saving money so that they have more budget available to do things like restore windows. So the other gradation, if you will, is that typically things that are close to the ground, people can really look at carefully. So for instance, the state of Vermont prioritized repairing windows on a recent project along the street level, whereas the higher windows were allowed to be replaced. So for a couple reasons, these windows, also just the sheer necessity of having an egress window dictated that this building, which is in New York, had to change its operation from double hung to casement. And that way it made.
What was the glazing on that? Was it single glazing or was there some sort of double glazing in that?
Oh, it's a modern window.
Yeah, that's what I thought. Yeah.
Retrofit window.
Yeah.
So
it's probably double glazed.
Oh yeah, definitely.
Yeah.
One thing most people who are in the design field know this is you can get a wider muntin that mimics a meeting rail. And you can actually, with Marvin, you can offset the panes of glass to really make it look like a double hung. There's quite enough charge on that. So anyways, again, all of these, we could call them compromises, but we'll try to call them optimizing budget and outcome. These are all fine scale, detailed decisions in the context of a large overall project.
Also, Rick Kirshner shared a comment that, that there is often a preference for interior storms because it's always best to have the tightest window, the most well sealed against air infiltration on the interior. But I think that works better in a museum setting than it may work in many homes. Although having said that, if you're comfortable with removing them, seasonally, and storing them, it's a valid and good option. I still worry about protecting the primary sash myself, giving that added life to the primary sash. But again, these are the trade-offs that we all struggle with. Now, I saw something that came in here. There's another comment from Elizabeth. You can repair your historic window, install a storm, and still meet egress. The storm just needs the same clear opening requirement as existing windows per DFS guidance. If the measurement is tight, you can have the storm panel on a hinge so that it's operable for egress. Thanks, Elizabeth. That's a really good point. And
Someone else made a point, Judy,
mhm.
about Green Mountain Windows. I have really enjoyed working with Green Mountain Windows, and I do want to put in a plug for local companies. They're a terrific company, and they do have a lot of customization possibilities that are not crazy expensive.
Okay.
So
And
ways to
then
make an assembly work.
there is also a question about inserts and wood stove metal flues installed in masonry chimneys need to be air sealed around the metal at the damper with more than just fiberglass or rock wool. Without the air sealing, it creates a chimney around the fuel that is exhausting conditioned air continuously and shows up dramatically in blower door tests.
Absolutely, that's such an important point. If you're putting an insert in that covers the entire opening, that can help. But yeah, that definitely needs to be looked at. I actually that is a theme that's run through with a couple of comments from Bob Neild about the balloon framing. I mean, I think people really need to be aware when they have good intentions about blocking something up or not thinking about that they need to block something. It's important to be thinking three-dimensionally about the issue, not just two-dimensionally in and out.
Okay, here's a question from Jay.
Yeah.
Does adding a sprinkler system avoid the need for an egress window? Also, if an apartment is above a business occupancy, the sprinkler will reduce fire separation requirement between different occupants from 1 hour to half hour, which is easier in an historic building. Does Burlington require new apartments to have sprinklers? Do other towns require sprinklers in apartments?
They're good comments. Often in small areas, it's easier to try to figure out the egress than to introduce sprinklers. So that was definitely the case in this project. And the whole mandatory sprinkler issue is a big political debate that we need to talk about some other time. It was definitely big in Montpelier. Judy, Lisa just asked a really good question that we wanted to talk about earlier a little more, which is brick walls.
Sure.
And here we're talking about load-bearing brick walls, not veneer brick walls. I don't know, Bob, are you still available?
No, I'm still here.
Being an engineer, you may not want to talk about insulating brick walls. I'd be curious with Anne and Alex and Lisa, anybody who's had experience with them, but my experience is to leave well enough alone. And again, to address the direct path kind of air leaks, but
Are you talking about brick walls, Sandy?
load bearing.
Can I just ask, in a case, I mean, I have a case where a former warehouse is being transformed into apartments. So the use is changing and an exposed brick wall is going to be within apartments. And the team just determined that that was not something they could leave uninsulated because they couldn't afford to overcome it with the HVAC system, the discomfort issue. And so I guess my question is, I've had advice, but I wonder if there is only one way to really answer the question, which is with a multi-$1,000, study by building science or somebody. Is that the only way to really address this reasonably or responsibly?
The answer is probably yes. One of the I had a project that just opened up recently in Springfield, and building science did it's a 3-story classic turn of the century brick building being renovated for apartments. And essentially what they said in the end was keep the water away from the building, get decent overhangs and take care of splashback, and then air seal and minimally insulate. So they're talking about just a couple inches of spray foam on the inside, and that was where that one was left. And there wasn't it was a pretty entertaining, long, detailed report, but the conclusions in the end were pretty basic. And it's I think they did look at the characteristics of the brick and try to understand, where which bricks were more susceptible to freeze thaw. And so, but I don't think they got into a serious thermodynamic review of the wall and how the moisture and temperature was moving through there. So that was what they had done.
Jay White raised his hand.
Yeah, I just have a comment about that on the Richmond Town Hall that I think Ann Cousin introduced me to solve a problem where they had insulated the brick walls and then immediately found that the bricks were falling off at the bottom. They think primarily because they were now, water was getting trapped and freezing because it was no longer being heated from the interior. And it was a major problem of how to keep all of the bricks from spalling. And they asked me how to get the insulation out of the walls. And I didn't really have an answer for that. It was a two or three story building. And I didn't really have a solution to get the insulation out after they put it back in. But their goal was to remove the insulation completely.
I think
Jay, can I just quickly ask, was that insulation, like they had interior finishes, so it was between the brick and the interior finish?
Yeah. They had a brick wall, and it was a high school that was turned into the town offices, and there was a stud wall in between the interior and the brick, and they insulated the stud wall, and then they found that the brick was spalling. They were also getting a lot of rising damp up from the ground into the bricks, and that was part of the problem. I think they also had a lot of snow melt from snow falling off the roof, sitting against the brick most of the winter, and that caused the bricks to absorb a lot of moisture because the bricks were fairly soft. They could easily spall off, and it was a problem.
I think it goes back to Rick's earlier comment of step number one is push that water away from the building as far as possible. Stop that either bulk water pushed up against it or the seepage from below.
Yes.
I'd be curious, to Bob's point about the building in Springfield, of what R value they were pushing for after with spray foam. So, if it's a pretty low R value, could you attain the same amount with a foil face foam and maybe adding a vent space between the brick and the foam and then adding your finishes?
Oh, wait a minute. I mean, I would recommend something more like an open cell foam with no vapor barrier. And on the sheetrock, just use a latex paint that's intentionally not low perm, and actually let it breathe.
Yeah, that's a great point, Sandy. I mean, and I think Roxol could also, Roxol is a pretty good drying.
Roxol's great. Roxol's a great material.
So
however they're applying it, if you have studs, you can put it in between as a mat.
I was just curious, to Bob's point of, what was their aim with the spray foam? Was it just an air barrier? Was it air and vapor? And then, there's other ways of kind of meeting those requirements.
We have a question from Death Row. He's raised his hand.
Yeah, I think this is a good discussion, especially when it comes to preservation, because in my understanding, and I've done quite a bit of research on this, that you really can't insulate the inside. I mean, and because of the risk of not just like water, like bulk water, but you got vapor drive coming through. And if you insulate the inside, I mean, you could totally deteriorate, your structure of your bricks if it's an actual structural brick. And so it does run the risk of, like, without, insulating the outside and, disrupting the character of the outside, you have to be so careful not to insulate when you insulate the inside. Like maybe you could get away with doing something with like rock wool or some sort of I don't know. I think even open cell foam would be risky. I mean, it's a serious thing, and it definitely takes very smart folks and some serious building science to be involved with. From my understanding, you have to be very careful insulating inside of a brick wall.
Doug Duloc may also have a comment about a project.
Well, I would just comment that it really does depend on the building and, you know, how many layers of brick and how solid the brick is and even how hard the brick is. I've done a couple of things at Dartmouth College. We fully gutted the building. We furred the inside, spray foam insulated, closed celled on the inside to prevent, you know, water migration through the wall. And then we fully flood coat sealed on the exterior of the brick to prevent water migration from the interior. And we were dealing with brick thicknesses that were 36 inches, you know, on the lower floor, up to 18 inches thick on the upper floor. So the Simpson Gumpert did the study life cycle report on, you know, the wall conditions, and basically came back and said that you won't have a problem with thick brick for, you know, 100 years, 50 to 100 years. So in that case, the client elected to fully insulate the building. I can't recall even what the R values were, but with I think it was even Unray Fanal that did the spray foam on the inside. So I think it really depends on your building and your brick and your conditions. And I'd still recommend to get a report.
Mm-hmm.
Someone brought up a question about the void between load bearing portions of a masonry wall. There is indeed often a cavity between, and the reason why that cavity was there was to create a moisture break, so that moisture couldn't migrate as easily all the way in. My understanding, which I have to say is limited, but my understanding is that that void is really important and should not be filled with foam. That was the question someone asked. I think that is was actually, I mean, I think we forget how ingenious people were 100, 150 and 200 years ago and coming up with solutions for very old, long time problems. And that may have good intentions, but if we don't understand why the void was there in the first place, we could really mess it up.
One thing to add, Sandy, with some of my projects, the brick on the exterior is usually really hard brick, and then they use what's called punk brick for some of the interior brick, which literally when it gets wet in the freeze thaw will dissolve. So you really need to understand your brick too.
Very good point.
We have a question from Las Gangas.
I like to, I agree completely with, was it Dave who was talking just now? Doug, sorry, with Douglas. You got to know your brick. If you don't know your brick, you're going to really create serious problems. We've restored a number of historic brick structures, and we've pretty much called in building science almost every time. And we've had it where they've come in, they've said, wow, this brick is great. It can handle it. It depends on the number of layers of brick you have. And, you know, sometimes they've said insulated to this amount, or it's safe to insulate to that amount. We've had one building that we had tested, and the brick was so poor that they said, don't insulate it, because if you insulate it, the brick is just going to freeze and thaw, and it's going to pulverize. You're not going to have a wall left. So brick buildings, to try to do them just without testing that brick is very dangerous. you're just taking big risks. And if you're not willing to pay the money to test it, then you should just leave it alone. You know, that's the best advice I've gotten, because every time we've brought building science into it, there's always been a different solution. It's never been consistently the same. But it's just that it's too big of a risk to take. Those are my thoughts.
Thank you, Laz. Josh Crandall's hand is raised.
Can everyone hear me? Sorry about that. I just want to echo a couple of comments that were really smart and on point. And you know, reach out to a building scientist before you head down the road of design, and find out how much and what it's appropriate for insulating that building. And to Sandra's point, that interior empty wide or space is to establish a drainage plane, so water just does not freely migrate through the multi-wide masonry assembly. So yep, first step for any building like that in insulation is get your WUFI analysis done and establish the ability of that masonry to take on any additional moisture load. Thanks.
Thank you, Josh. And Malcolm?
Can you hear me?
Yes.
Yeah, okay. I own, excuse me, an 1850s farmhouse that had been renovated for 20 years. And the window situation really became pretty complex because there were some later additions, and some windows were casements and some were double hungs. So what I tried, and it seems to work on the double hungs, I actually hinged storm windows on the exterior, and what that meant that the outside of the windows were protected, you know, in the wintertime, and then I hinged them out and actually got some stays that held them out during the summertime, and the windows were protected from rain because it was hinged out. The ones that were casements, I did the same thing but in reverse, and so the casement windows had storm windows on the inside, hinged, and in the summertime I actually hang them up from the ceiling on chains, and then I can insert screens in the space where the storm windows were. So it was a real combination of just trying to figure out what was right for different circumstances. So I just wanted to pass that on.